All right, everyone, welcome. Today, we're going to tackle a super important concept in Java, the map. Ever used a dictionary? You look up a word and you get its definition, right? Well, that word and definition combo is a perfect real-world picture of what a map does. So in this explainer, we're going to break down exactly how maps work in Java, why they're such a game changer, and how you can use them to handle your data way more effectively.
So, what's on the menu today? First up, we'll talk about why simple lists just don't cut it sometimes. Then, we'll officially introduce the map and its whole key value thing. After that, we'll jump into some actual code with HashMap. We'll also see how to mess with the data inside a map. Then comes a big one for any interview, HashMap versus Hashtable. And finally, we'll wrap it all up with a quick recap of the most important stuff. All right, let's kick things off with Section 1, Beyond Simple Lists. We're going to look at why things like arrays and lists can be a bit of a headache and how maps come to the rescue. Okay, picture this. You're a teacher, you've just graded a test, and you've got a bunch of student marks. How are you going to store that information in your program? This is a super common scenario you'll run into all the time as a programmer. Now, your first instinct might be, hey, I'll just use a list or an array. You could just throw the marks in there, like 56, 23, 67, 92. I mean, it looks simple enough, right? But, as you're about to see, this has a major flaw. Yeah, here's the big question. Who scored what? Is that 56 Naveen's score, or is it Kieran's? You see the problem? We just have a bunch of numbers floating around with no real context. There's no connection between a student and their score. So, take a look at this comparison. On the left, with a list, you're stuck using a number, an index. If you want that first score, you have to remember it's at position 0, so you write marks 0. But look at the right side with a map. It's so much more intuitive. You just use the student's name as a key, like marks.getNaveen. It just makes sense, doesn't it? It's way easier to read and a lot harder to mess up. And that little problem leads us perfectly into our next section, where we're going to officially meet the solution, the map. Let's dive in and see how this amazing data structure helps us link our data together. So what in the world is a map? Let's go back to that dictionary idea. A dictionary has words, those are your keys, and for each word, there's a definition. That's your value. A Java map is literally the same thing. It's just a collection of these key value pairs, where every single key is unique and lets you look up its value. Let's bring it back to our students. The student's name, say Kieran, becomes our unique key, and their score, 92, is the value. The map forges this direct link, this logical connection between the key Kieran and the value 92. It's a really simple idea, but it's incredibly powerful for keeping your data organized. Okay, now for some really important rules about maps. You absolutely have to remember these, especially for exams. Rule number 1, keys are unique. It's just like a set. You can't have two students with the same ID number, and you can't have duplicate keys in a map. Rule 2, values can be duplicated. That makes sense, right? Two different students could totally get the same score. And rule number 3, and this is a big one for HashMap, the order is not guaranteed. This means the order you put things in isn't necessarily the order you'll get them. All right, that's enough theory for now. Let's get our hands dirty and actually write some code. In this section, we're going to see exactly how to use a hash map and bring our student marks example to life. Okay, first things first, you gotta declare the map. You'll write something like map string integer students. So map is the interface, and those things in the angle brackets, those are called generics. They're telling Java what kind of data we're storing. In our case, string for the key, that's the student's name, and integer for the value, that's their score. Next up, we have to actually create the map object. Now, map itself is just an interface, like a blueprint, so you can't create an object from it directly. You need a class that actually implements that blueprint. The most common one you'll see is HashMap. So our line of code now looks like this. Map, string, integer, students equals new HashMap parentheses. So how do we get data into our new map? Well, with a list, you'd use the .add method. For maps, the magic word is .put. So to add a Harsh's score, you just write students.put Harsh 23. And just like that, the key Harsh is now permanently linked to the value 23. And voila! If we add a few more students and then print the map, this is what you get. See how each name is perfectly paired with a score? It's so much clearer. But also, look closely at the order. It's all jumbled up, right? It's not the order we put them in. That's that classic hash map behavior I was talking about. You really got to remember that. Okay, so we know how to create a map and fill it with data. Let's move on and learn how to actually work with that data once it's in there. We're going to cover two super important things: how to update a value and how to loop through everything in the map. This next one is a classic interview question, so listen up. Let's say we made a mistake and Harsh's score was wrong. What do you think happens if we use the dot put method again with the exact same key, Harsh, but a new score? The answer is it just updates the value. The map is smart. It sees the key Harsh already exists, so instead of creating a new entry, it just replaces the old value with the new one. It's just like editing a contact on your phone. You don't add a new person, you just change their number. So now Harsh's score goes from 23 to 45. Easy. Okay, what if you want to print out a nice list of every student and their score? You can't just use a simple for loop like with a list. But don't worry, it's a simple three-step dance. Step 1, you grab all the keys from the map using the dot key set method. This gives you a nice little set of all the names. Step 2, you loop through that set of keys. And finally, step 3, inside your loop, for each key, you just use .getKey to pull its matching value out of the map. All right, let's switch gears to a topic that comes up in job interviews all the time: the difference between HashMap and Hashtable. I know, they sound almost identical, and they work in similar ways, but trust me, there are some critical differences you absolutely have to know. This table here breaks it all down, but let's focus on the big one: synchronization. Hashtable is what we call synchronized, which basically means it's thread safe. Now, what does that mean? It means if you have multiple parts of your program trying to access the map at the exact same time, think of a busy server or a banking app, Hashtable keeps things from getting chaotic. But that safety comes with a price. It's slower. HashMap, on the other hand, is not synchronized. It's way faster, but it's not safe to use in those multi-threaded situations unless you handle the safety yourself. Whew, we have covered a lot of ground today. So before we wrap this up, let's do a super quick recap of the most important takeaways. This is the stuff you'll want to have locked in for any exam or interview.
Okay, so let's boil it all down. First, maps are all about those intuitive key-value pairs. It's the whole point. Second, and this is a big rule, keys in a map must always be unique. Third, that handy .put method is your tool for both adding new data and updating old data. And finally, the big showdown. HashMap is your choice for speed when you only have one thread, but you have to use Hashtable when you need that built-in safety for multi-threaded applications. Got it?
And there you have it. That's your crash course on the Java map. So now I've got a question for you. Think about the next project you're going to build. Where could a map make your code cleaner, faster, or just easier to understand? And hey, don't stop here. HashMap and Hashtable are just the tip of the iceberg. You've got other cool implementations like linked HashMap, which actually remembers the order you put things in, and tree map, which keeps all your keys sorted. Definitely go check those out next. Thanks so much for tuning in today.